How do collisional cascades explain planetary rings' evolution? Imagine a giant cosmic game of breakage where pieces of space debris keep smashing into each other, creating a never-ending chain of smaller and smaller fragments. That's essentially how planetary rings evolve through something called collisional cascades. When a large moon or satellite near a planet gets hit hard enough, it can shatter into a variety of pieces. These pieces range from big chunks to tiny dust particles. Once broken apart, they start orbiting the planet and bumping into each other. Each collision causes some fragments to break into even smaller bits, setting off a chain reaction. This process keeps going, constantly reshaping the ring system. Take Saturn's rings as an example. Scientists have found tiny moonlets inside the rings that are just tens of meters across. These moonlets are thought to be leftovers from a larger moon that was smashed apart long ago. The debris from this event spread out and collided over time, creating the bright, detailed rings we see today. Because these moonlets are constantly hit by other particles, they don't last forever. They break down into dust, which can drift away or be pulled into the planet. This ongoing cycle of breaking and rebuilding helps keep the rings looking fresh and vibrant. The process of collisional cascades explains not only how rings form but also how they change over time. Larger particles gradually turn into dust through repeated impacts. This dust can be lost from the system or redistributed, which influences the rings' appearance and lifespan. The size distribution of particles in the rings matches what scientists observe, mostly tiny dust with some larger chunks. This balance between breaking apart and losing material determines how long the rings last and what they look like. In essence, collisional cascades are like cosmic sandpaper, grinding down big pieces into fine dust while constantly renewing the ring system. It all begins with a major impact event, like a moon being shattered, and continues as the fragments collide and break apart again and again. This process shapes the structure of planetary rings and influences how they change over millions of years. Did you know that the rings you see today might be the dusty remains of a moon slowly crumbling through countless tiny collisions? It's a fascinating dance of destruction and renewal happening right above us in space.